Evening, I'm Spot On Weather meteorologist Matthew Euler. Welcome to my latest video. This one's titled Battling Teleconnections. There's a major battle that's been occurring with the various teleconnections. This is something that's known as destructive interference, and I'm going to delve into that specifically in tonight's video. And also I'm going to kind of do a little sneak peek on up into the week of Christmas, leading up to Christmas, and kind of tell you what my thoughts are regarding the weather pattern by that point in time. Here's the title slide tonight. Hopefully everybody's in the holiday spirit, showing Santa Claus. There's Santa Claus there with all of his reindeer. And, it's getting to be that time of year. What kind of weather will Santa see as he makes his journey delivering those presents this year? And, that's what I'm really going to get into tonight. So St. Nick is not very far out of sight at this point, as we're now sitting on the 7th of December already. It's hard to believe how quickly the time is passing. All right, so first things first, let's talk about this major battle that's going on, the battling teleconnections. Now, the PNA, which stands for the Pacific North American pattern, this is what it is saying, okay? The European EPS forecast for the PNA here is on the left, and then on the right here is the GFS ensemble forecasting system. So I'm looking at the two major ensemble groups here, European and then GFS ensemble. And if you notice the ensemble mean the green line here, okay, we're sitting here on the 7th of December, and both of these diagrams is generally over here to the bottom left. That's our starting point on both of these forecasts. And what you'll notice is this ensemble mean line, the average of all the model members, and for example, the European EPS has 50 perturb members, and then the Jeff's V12 uses 30 perturb members. So we have more members with the European EPS as compared to the GFS ensemble, the Jeff's over here on the right. Bottom line is this green line represents that ensemble mean or average of all those model members. And what we see in both cases, both models today, is a very, pretty significant negative trend to the PNA. And I'll show you what that means here in a minute on the next slide. But look how negative these values are in both cases, both models. And then in both model cases, notice how we get closer to this solid black line, the zero line here. And that basically indicates that the PNA is going to be trending up closer to neutral territory as we get specifically into around the 13th of December. So right now the PNA with this negative tendency is basically saying, hey, we should see an upper trough in the coldest temperatures in the western U.S. with a negative PNA, and then the upper level ridge and mildest temperatures across the eastern U.S. That's actually happening today, by the way. Now this is the major difference here. When you get a negative PNA, okay, I do show both positive here on the left. This is courtesy of NOAAclimate.gov, by the way. Positive phase, I'll just explain both, why not? So a positive phase PNA over here, the upper left, what we have going on is generally a deep area of low pressure in the Gulf of Alaska across the Northeast Pacific in a positive PNA phase. And then we get this huge upper level ridge with the ridge axis extending from the western portions of the U.S. on up into western Canada. And then downstream of that ridge, the height's lower, and you get more of troughing over the eastern U.S. That's with a positive PNA. Now with a negative PNA here on the right side, with a negative PNA, we just kind of flip the pressure systems, right? So with a positive PNA, low pressure in the Gulf of Alaska. With a negative PNA, now we have a sprawling area of high pressure in the Gulf of Alaska. And then downstream of this major upper level high, we have troughing and colder temperatures and unsettled conditions across the western U.S. And then we have this upper level ridge, which is influencing the eastern seaboard with a negative phase of the PNA. So see how these pressure patterns flip? You look at the tripole pattern, that means I'm looking at the pressure system in the Gulf of Alaska, I'm looking at the pressure system over western portions of North America, and then I'm looking at the pressure pattern, pressure system over the eastern portions of North America. So see how we go low, high, low, west to east with a positive PNA, and then with a negative PNA, we switch it around now, we flip it. We have a high, low, and then another high. All right, so we kind of know now with a negative PNA what we're situated, what we're currently seeing right now, what type of weather pattern we're seeing in the upper levels. I'm not even going to bring up today's chart, upper level chart at 500 millibars, because this negative phase PNA completely describes what's going on right now, to be honest. We're seeing a huge upper level high today in the Gulf of Alaska. We're seeing that troughing, that persistent troughing, a lowering of heights, more colder temperatures and unsettled conditions across the west. And then we're also seeing east of the Mississippi River, we're seeing this subtropical ridging that's extending from the Gulf of Mexico northward. So this negative phase PNA is pretty much identically spot on with what's going on today in the upper level chart. What about the NAO? Now, PNA is saying, hey, milder conditions across the eastern U.S., but the NAO says, wait a minute, what about me? Negative in both cases here. We're looking at the same models here, European ensemble left, and then the GFS ensemble forecast on the right. And we're still looking at this green solid line. That's that split right down the middle of all the model members, or the average of all the model members. And look how negative we're going here with the North Atlantic Oscillation, the NAO, specifically between the 10th and the 13th of December. On the European here on the left, and then as well, very similar here with the GFS ensemble on the right. Sharply negative NAO, very strong upper level ridging and blocking that's occurring from Greenland. It's eventually going to retrograde or extend further west from Greenland over time. But so this kind of negative phase of the NAO, that should favor troughing and coldest temperatures in the east, the exact opposite of the PNA. All right? This is called destructive interference. In other words, these teleconnections are not aligned in a certain manner in which they're all working in the same direction. We have the PNA acting in opposite direction to the NAO. With a negative NAO, we should see the ridge and the mildest temperatures in the west. We're not seeing that. All right? So that tells me right now that PNA is playing a significant role in what's going on right now with the pressure distribution in the upper air pattern. What happens with a negative NAO phase? Look at this. This is the 500 millibar height anomalies. 500 millibars being up at about 18,000 feet above the ground. This is what happens with the height anomalies in the upper levels of the atmosphere during a negative NAO. We have this anomalous ridging that's occurring in the vicinity of Greenland and working its way westward towards Baffin Bay as well as towards Hudson Bay. And beneath that upper level ridging in this anomalously high heights, we have lower heights extending across the mid-latitudes, the U.S., the lower heights working their way across the Atlantic into portions of Europe. So we have, generally with upper level ridging, or higher than normal heights, we generally have milder or warmer than normal temps in the high latitudes, and we have colder than normal temps in the mid-latitudes with a negative NAO. This is the pressure pattern that sets up. Okay? What do we get here with surface temperature anomalies? Look at this purple and blue coloring. This indicates very cold air draining southeast from Canada and Alaska straight into the U.S. Anywhere from the Rocky Mountains to the East Coast is below average as far as temperatures go when we have a negative NAO. This is traditional negative NAO, okay? Now, what about La Nina? What does La Nina say? Right? Look what's going on today with the sea surface temperature anomalies map, courtesy of tropicaltidbits.com. Blue coloring below normal water temperatures, and it sticks out like a sore thumb. We have below normal temps from just off the coast of South America all the way over, all the way past the international dateline, in fact, along the equator. These are this is the latest value for the Nino 3.4 region as far as temperature anomalies in degrees Celsius. And look at this. This is interesting. You know, I did a teleconnections video last Friday. All right? Last Friday. What was that, the 2nd of December? Look how much it's dropped just since last Friday. The current value for departure from normal of those water temperatures in Nino 3.4 region is minus 1.22. So we definitely have La Nina, and it's a moderate one now. It's definitely established as a moderate La Nina at this time. This thing is supposed to, per the latest climate models, start weakening. So let's keep watching this trend. The ridge and the milder temperatures in a La Nina year are usually in the eastern U.S. You usually have more ridging. A drier and milder situation across the southern U.S., up in the southeast, the mid-Atlantic, with a La Nina. So a La Nina would indicate a ridge of milder temps in the eastern U.S. with a trough and colder temperatures in the Pacific Northwest, more specifically, and the northern U.S. All right? So La Nina generally favors a situation where we get this huge blocking high pressure over the Gulf of Alaska, and this purple line represents the polar front jet stream. But look what happens here. With a La Nina winter, the coldest temperatures are from eastern Alaska, working their way into the western provinces of Canada, even into parts of central Canada and then the Pacific Northwest of the United States, over to the northern plain states. But you notice this? Look at this in the mid-Atlantic. Look at this in the east. Look at this in the south. For the typical La Nina winter, we see drier than normal conditions. We see warmer than normal conditions and drier than normal conditions all the way up to the mid-Atlantic, right around DC southward. We also see a little area of wetter than normal conditions for the winter time with La Nina across the Ohio Valley, Indiana, Kentucky, Ohio, West Tennessee. Those general areas are wetter than normal typically. All right? Now with La Nina, look what happens. The vertical circulation that happens far, far away from us here in the middle latitudes in the United States specifically. Look what happens with a La Nina. You get strong upwelling. So I get cooler water, deep cold water that gets upwelled. It gets upwelled towards the surface off the coast of Lima, Peru. Because we have stronger trade winds, which blow basically from east to west across the equatorial areas of the Pacific, from the eastern portions all the way to the western portions of the equatorial Pacific. And look what happens. Stronger trade winds, the stronger winds tend to take this top layer of water and push it west. That's going to result in you notice how the water levels decrease here when you're pushing more of that wind is stronger trade winds are pushing that surface layer of water further west. We get this strong upwelling coming up from the deep areas of the ocean. And that's why you see below normal temperatures associated with La Nina. You're getting that upwelling situation. And then look at the circulation in the ocean. See this? All right. So your surface layer of water tends to move towards the west, and then it tends to sink again. But look how much deeper this water column is over the western Pacific associated with warmer than normal water. So we have warmer than normal water over the western Pacific equatorial areas. We have colder than normal waters across the eastern equatorial Pacific areas. And look at the atmospheric response above that water circulation. We're seeing stronger trade winds, as I already mentioned, and we're seeing rising or a more greater propensity for rising air motion, showers and more unsettled weather, thunderstorms, convection over the waters, those warmer than normal waters of the western Pacific. And then we see over the upper levels of the atmosphere, that circulation basically goes from west to east, and we have sinking air motion in the eastern Pacific over the equatorial area, generally over those cooler than normal waters with La Nina. So this whole circulation cell that sets up, see this? We're talking about the surface, stronger trade winds blowing from east to west, enhanced vertical air motion. Now, La Nina, you're typically looking at, enhanced rising vertical air motion over the western Pacific Ocean in those MJO phases 6 and 7. And then you see that sinking air motion again. So this is one big circulation cell we have to pay attention to. This energy redistribution due to this rising air motion and sinking air motion, this impacts the overall circulation far, far downstream from this. Here is a combination. Now I wanted to take a look at tonight's video, the combination of a negative NAO, the North Atlantic Oscillation, plus La Nina. All right. So the way this is divided up here, the graphic here, we're showing you temperature departures from normal. Blue below normal, aqua color and green slightly below normal. The darker blues are more significantly below normal. And then you see the color scheme here with the maroon colors and the oranges. The more darker maroon indicates extremely above normal temperatures. Okay, so what do we have going on? Left-hand column here, these three on the left, this is associated just in the month of December. What happens? The middle three vertical here, all January, and then the far right are all February. Okay, so let's just take a look at December. We're in the month of December now. We have a strongly negative NAO. We do have a La Nina. Now this upper left-hand graphic is the December of all La Ninas. In general, what you would expect overall. Okay, notice the milder than normal temperatures across the southern U.S. and even, kind of extending northward there into the mid-Atlantic. The coldest temperatures remain over the northern U.S. But what happens now here in this particular graphic, here on the left in the middle, we're now looking at Decembers with a negative NAO in La Nina winters. Negative NAO plus La Nina winter in December. Look at this. Look at how much different this is, okay? Look at this. Look how much below normal these temperatures are. And they extend from parts of eastern Montana, the northern U.S., Great Lakes area, down to the mid-Atlantic, basically all the way into New England. See how much below normal these temperatures are in the month of December when you have a negative NAO with a La Nina? Now look at the bottom left here. Far left, bottom left here, corner here. Look at this. This is a positive NAO with La Ninas in December. And whoa, it's like we just flipped the switch, right? Look how much above normal the temperatures are in Decembers with positive NAOs and La Ninas. From the Rocky Mountains all the way to the East Coast, completely way above normal in temperatures. And then the one cooler than normal areas out in the western U.S., including California, Nevada, the Four Corners region. What happens in January? Look at the middle vertical row here, these three particular images in the middle, from top to bottom. In January and all La Ninas, this is pretty much what the National Weather Service, or NOAA, has come up with for this year's winter outlook. They look at all the La Ninas and they go, okay, looks like they'll be ridging over the southeastern U.S., so above normal temperatures and drier than normal conditions, and then we'll keep the coldest temperatures back over the northern plains, the Pacific Northwest. This is a typical La Nina in pretty much the whole winter. I'm showing you January, and in February is pretty much similar over here in the upper right with La Nina. See the ridging? See the above normal temperatures? This is where you're going to get the ridging and the drier than normal and warmer than normal winters. But now let's go back to January. With a negative NAO in January in La Ninas. Look how cold the United States is from coast to coast. So let's say next month in January we get another Greenland block and a stronger blocking situation. We could see a strongly negative NAO if we do, plus the La Nina winter that we're seeing. Wow, we could really have a cold January. And then bottom here, here in the middle, bottom row there, center row in the bottom. This is January's with a positive NAO plus La Ninas. And look how much above normal again. So you don't think that the NAO really makes a difference here in La Nina winters? This right here just proves it, okay? We compare negative NAOs versus positive NAOs with La Ninas, the combination. It's just night and day, especially in the months of December and January. Negative NAOs with La Nina in winter generally equate to much below normal temperatures from the northern U.S. to the East Coast. A positive NAO and a La Nina in December and January, much above normal. So, why do I say this? Because we have this going on right now. Now, am I factoring in the negative PNA in this particular consolidated plot? No. But I will say, in the month of December, during negative NAOs plus the La Nina conditions, the coldest temperatures have historically been over the eastern U.S. They've extended further to the East Coast. We have not seen that yet. Now, the ensemble forecast showed a colder temperature outlook initially for the majority of December, outside of the first week of December. Last time I talked to you on the teleconnections video last Friday, 2nd of December, I was telling you potentially about a pattern change. I can't remember the exact date I gave. I think it was around the 12th of December, but I might be a little bit earlier than that on my video. So what's happened between that last video I did last Friday with the ensemble forecasts? This is what's happened. Okay? This is what's happened. We have now seen, by the way, this is a European EPS, 500 millibar height anomalies in decameters, and then heights in decameters and the height anomalies in meters. There we go. All right, what do we have going on? Maroon coloring, upper level ridges. So we have one. This is this is actually, let's see, this is actually a forecast out for next Tuesday, the 13th of December. So my initial thought with the ensemble forecasts, all of them were in great agreement, showing a pattern change with colder air moving to the east, which lines up nicely with what we're looking at here, December, negative NAO and La Nina. But then we ended up getting this. We ended up getting this ridge generally poking up from the Gulf of Mexico northward into the Ohio Valley, stretching all the way up and connecting to this major Greenland block, basically this stronger negative NAO ridge. And then we had troughs over the western Atlantic, lower heights, and we had a major trough over the Rocky Mountain area, the western U.S. Then there's another ridge position basically over the Aleutian Islands extending northward to western Alaska into the Bering Sea. And so, you're looking at this and say, wait a minute, look at this ridging over the east. Why is that happening when, this is the combination of negative NAOs plus La Nina in December? It should look like this. It should look like this. And, we're not talking about just a couple years here on these composites, okay? We're talking about, if I blew that up, let me see if I can blow this up. Let me see if I can blow this up. It's hard to read those numbers, so please forgive me here. Oops, I'm all over the place. But we're talking about, at least 1, 2, 3, 4, 5, 6, 7, 8, 9 different nine different Decembers with a negative NAO in La Nina. Okay. Yeah. That many. Okay, so we weren't just talking about a few years here. Please forgive me on this. I gotta get back to where I was. Okay. So I just wanted to kind of show you that what's going on right now, again, is this is the forecast for next Tuesday, the 13th of December. So basically, the bottom line here is this pattern change or this colder regime in the east is being delayed. It's pushed to the right because of this the forecast upper air pattern for next week, early next week. And then, look, the models have gone milder in the east, keeping that trough across the western U.S. with that negative PNA. That negative PNA has been a little pesky if you want colder temperatures to shift to the eastern U.S. And other thing I look at when you look at prolonging, pumping this ridge up in the east in the forecast is where does the baroclinic zone set up? Now, what is the baroclinic zone? It's just simply the boundary between the milder and colder air. And that boundary is going to set up right in this area. The storm track is going to basically run right along it. You're going to have your main jet stream axis overhead, with your jet streaks or jet maxes. That's going to provide the upper level support for storm development. Basically, what the storm is relying on is it's tapping into this stronger temperature thermal gradient between, from ahead of the cold front to behind the cold front. So it just taps into this energy, changes that potential energy to kinetic energy or energy of motion. So we got a baroclinic zone that just sits out here over the western, the portions from, Kansas up to Minnesota, over the Midwest. And every time these low pressure systems form along this baroclinic zone, they just pump up the ridge east of those low pressure areas, and that just keeps the east warm. All right. Pumps in those higher heights and the milder temps over the east. Every time you get a storm track to the west like this, over the Midwest. What about the MJO forecast? How might this kind of be involved in delaying the onset of the pattern change across the eastern U.S.? Well, this has changed significantly, I'll be honest with you, since my teleconnections video last Friday. This is the latest forecast plot, right now in the null phase. But if you notice over time, it rotates back around out of the null phase eventually into weak phase 1, weak phase 2. Now, a phase 1 and a phase 2 in December is still fairly cold nationwide. Either of these phases, phase 1, phase 2. You notice this blue coloring indicates below normal temperatures. You notice how the blue coloring reaches the east coast in both phases 1 and 2, right? Okay. But if we can convection over the Indian Ocean into phases 2 and 3, specifically 3, look how mild things become across the eastern U.S. in phase 3 during the months of December, January, and February. So where is the convection going to predominantly set up? Right now we're in the null phase. This forecast runs out to the winter solstice on December 21st. Now, what about the temperature roller coaster? Being that we're seeing these more of a progressive pattern taking shape across the United States, I'm expecting to see a temperature roller coaster through the 15th of December for the east. All right, here's a prime example. This is the forecast for next Wednesday evening, the 14th of December on the left. Okay, and both of these are for the 14th of December. This is next Wednesday evening. And so on the left, I have the European Ensemble Prediction System. On the right, I have the GFS Ensemble. All right. So you'll notice the patterns in fairly good agreement here. Okay. We're seeing a trough setup, a closed low over southern Minnesota with a trough axis basically extending southwestward. We're still seeing the ridging though in both of these models for next Wednesday evening. More of that upper level ridging occurring along the East Coast. So that means mild. But before this midweek next week, it's interesting because the models are trending a little bit colder with a system this weekend and early next week. From New England right on down along the coast of the Mid-Atlantic, there's an area of colder air that's going to sneak down before this ridge moves in. And so that looks really interesting. I call it sneaky cold. Could drop into the Mid-Atlantic from the north by Monday, the 12th of December. So early next week, it was looking much milder, let's say 24 hours ago. But now it's looking colder. But then this ridge progresses from west to east right into the eastern seaboard, and it's going to get mild again. There's going to be a strong surface cold front that is going to be just to the west of the Mid-Atlantic by next Wednesday evening, the 14th of December. What I want you to really pay attention to in both of these images is look at this brown coloring, look at the maroon and the bright, the darker oranges. This is very, very significant. See how this area up over northern Canada is pretty much dominated by higher than normal heights? That's what these colors indicate. The browns and then the maroons and the brighter oranges indicate above normal heights. This basically is an area where it shouldn't be happening, okay? It should be the reverse here. We should be seeing these blue and green colors up here, and then more of the maroon coloring, the orange coloring down here in the mid latitudes. So right now the atmosphere is completely out of the norm. It's anomalous. This is an anomalous upper air pattern. And what it is we're talking about blocking over the top. It's setting in by the 18th of December. Now this would be not this weekend, but the following weekend. So we're about 10 days out from this. But the similarities in the model output, models are starting to come around now to more of this. Blocking over the top. We have both Pacific side merging with the North Atlantic side as far as the ridging goes, and we got a complete block over the top. And below that, we're going to have a lower than normal heights across the whole entire United States, really. So what does that mean, lower than normal heights? That means colder temperatures. Lower than normal heights is colder temperatures. So this is the 18th. This is Sunday, the 18th of December. Right. So now let's take a look at some of the temperature anomaly forecasts. Let's look at the European mean, the European ensemble system mean. On the left here is, I'm showing you the transition from the milder temperatures associated with this shortwave ridging here along the East Coast. This is the above normal temperatures in degrees Celsius according to the European ensemble mean. Look at the warmth from Florida on up through the Mid-Atlantic, even warmer than normal into New England. This is on Thursday morning the 15th. And then the European ensemble mean here on the right is the forecast for the Sunday, the 18th of December. Look how the maroons and the oranges got replaced with greens and blues. So you see what's going on here? The colder air is pushing east. Looking at the temperature anomaly forecast for the EPS control, similar situation. This is Thursday, the forecast temperature anomalies in degrees Celsius for Thursday, the 15th of December. Look how much above normal things are up the I-95 corridor, up the East Coast. Coldest temperatures up over the western U.S. on the 15th of December. But by the time you get to Sunday, the 18th of December, look at the purples down here in Florida. You're going to be shivering down there if this verifies. You're going to go from very tropical summer-like to below normal in a hurry across the Sunshine State as well as the Gulf Coast by the 18th of December. And the cold is over the Midwest to the East Coast pretty much according to the European control. What about the GFS Ensemble forecasting system? Forecast here on the left, same time periods, 15 December, Thursday. Look how much warmer than normal conditions are. This is in degrees Celsius. Here is your chart here on the right showing you the values above normal. But cold west, warm east on the 15th of December. And then look what happens according to the Jeff's V12 here, temperature anomaly forecast, the ensemble mean showing below normal temperatures coast to coast across the U.S. Coldest temperatures according to this model will be back over the Dakotas, Montana, and the Pacific Northwest and southwestern Canada. And then the CFS. Now, CFS, let me tell you, I know that a lot of people will criticize this model because, a lot of times it's way out to lunch, let's be honest. But when I consistently see this blue coloring, like below normal temperature indications from the CFS, I kind of raise my antennas a little bit because normally this model forecasts, it has a warm bias. It goes too warm usually. And so when I'm seeing coast to coast below normal temps here, this forecast here on the left is for the 17th, the 27th of December. Look how below normal the whole US is over the holiday period. And then over here on the right, this is the forecast from the CFS from the 22nd of December all the way to the new year, 1 January. See how much below, we're still talking about below normal temperatures. And so a colder look from 17 December to 1 January, a 2-week period according to the CFS. And again, this raises my antennas a little bit because usually CFS is a warm bias. So here are my final thoughts in tonight's video. We're going to see an up and down temperature swing between now and the 17th of December across the mid-Atlantic. There'll be days like today. Today, for example, in Virginia, we were looking at temperatures in the upper 60s for highs. It was a modified maritime tropical air mass. Dew points were sitting around 64 degrees Fahrenheit this evening with a temperature of 67. All right, but then by Sunday, we're looking at high temperatures in the low 50s. So we're looking at about a 12 to 15 degree Fahrenheit drop. And now I expect these swings to continue, all right? Due to this destructive interference, this battle between the teleconnections, negative PNA versus negative NAO. Of course, we got to throw that La Nina on the side of the negative PNA right now. Now, looking at these latest model guidance, it looks like there'll be a change to the upper air pattern. That subtropical ridge that's been so dominant from the Gulf of Mexico up over the central and eastern U.S. Let me go back here, right here. This upper level ridging here is finally going to be flattened out. By 18 December, we're going to then have a negative NAO, a more neutral PNA, a negative AO, and then one thing I didn't show you tonight is a negative EPO. Now, the latest models from today are showing this Eastern Pacific oscillation, this negative EPO taking shape, additionally, around this time period. A negative EPO, what does that favor? What does that do for us? That favors a stronger upper level ridging into Alaska. So now you're increasing your heights up into Alaska and along the west coast of Canada. And what that does then, it generally tends to shift the trough further to the east. The colder air will shift further east with the placement of that long wave trough. And so I'm not really showing you the graphics for this EPO. I usually do during the teleconnections discussions. So if you really want to get a look at that negative EPO graphically, feel free to go back and look at my video from last Friday, my teleconnections discussion on the 2nd of December, because I do cover that EPO. Overall, it's looking like a colder nationwide look from the 18th of December to the 25th of December. There's a lot of uncertainty as we head into late December and early January. Could it turn around to being potentially milder again for the eastern U.S. at some point in late December, early January? Yes, it could. But right now, the confidence is increasing that we could see a below normal period of temperatures across the eastern U.S. Basically the 18th of December right to Christmas Day. So what now I want to talk about is, okay, we have colder temperatures potentially moving into the east. And I know everybody's going to be curious. Does this mean there might be a white Christmas? Well, right now it appears the southern branch of the jet stream, so that some tropical jet is going to become more active. And we're going to have that colder air kind of moving down, the Arctic air slightly moving in from the north. That could result in that baroclinic zone shifting further south and extending more east-west. And that could result in more frequent cyclone or storm development in late December. More of a southern route. What you ideally want is that, with that negative NAO over the top, the blocking over the top, you want more Pacific, more active southern subtropical moisture getting entrained and moving across the southern portion of the U.S. You really want to see that with the colder temperatures sagging further south. That will lead potentially to a greater thermal contrast further south, which then that's the energy for the storm system to develop. This could lead to more wintry weather is what I'm getting at in late December for many from the mid-Atlantic northward to New England. And really, okay, all right, I'm going to mention something here, okay? Before I go and end this video tonight, I want to mention something very important. All right. All right, so what we need that 50-50 low, first of all. I mentioned it in one of my previous videos. What's a 50-50 low? It's generally when you get an area of low pressure that sets up, generally at 50 degrees north, 50 degrees west longitude, okay? What Uccellini and Cosin said from their Northeast Snowstorms excellent book, a cutoff low over eastern Canada with a blocking ridge downstream into Greenland. And in a lot of cases, what you get is cold air damming that's prevalent east of the Appalachian Mountains. And that generally, what that means is you get colder air that just, you get cold high here over Canada with the clockwise flow around it, cold northerly winds bringing colder air in the low levels of the atmosphere down along the east coast, east of the Appalachian Mountains. It's a situation that's known as cold air damming. And what it does is the colder air, you get a greater thermal contrast between the colder air associated with the cold air damming, and then you get that comparison of the colder than normal air over the land, east of the Appalachians, and the warmer air over the ocean, over the Western Atlantic. It creates a stronger thermal gradient. And what that does is it results in coastal storm development. But one of the main things I wanted to mention here, what we really look for is, okay, let's see. Snowstorms, okay? Snowstorms are more common during transition from a negative NAO to a neutral or positive NAO. The weather patterns during the negative NAO phase generally tend to lock in the colder air. But as a negative NAO pattern weakens or shifts, a storm system nearing the U.S. southeast coast has a better chance of moving up the east coast as a major snowstorm rather than eastward over the Atlantic. When you get the blocking up here, it generally does not allow the storm to more readily escape out to sea. So you tend to get storm development that moves up the east coast. And so taking these rules of thumb into account from the amazing book, Northeast Snowstorms, all right? All right. Let's take a look at our NAO forecast. All right, I kind of hinted at it there on my last. If you look at here, when is this starting to transition towards neutral? Look at this on both of the ensemble forecasts. Anywhere from the 19th of January to the 24th. Now, I don't have the 24th on here. I only go to the 23rd on this model on the right and the 22nd here on the model on the left. But the bottom line here is the NAO is easing. It's easing somewhere after the 19th and potentially going into about the 24th of December. All right, and that is why I listed this as a very favorable area for a specific development of a storm system, East Coast winter storm. That's taken directly from the research, amazing research conducted by Cosin and Uccellini, as a negative NAO pattern weakens or shifts. And what are the big things here again? Snowstorms are more common during the transition from negative NAO to neutral NAO or positive NAO. So we're heading into the peak of a negative NAO, right? When's that going to occur? When is the peak of the negative NAO going to occur? It's going to occur generally between the 11th and the 13th of December. This is when it reaches its most negative point or its peak. After that, it starts to come up, starts to rise and climb closer to neutral. That is the time, 19 to 24 December, we literally could have a Christmas storm this year if all pans out according to the way the models are looking right now. So I'm going to leave you with that tonight. I thank you so much for your attention and for taking the time out of your busy life to watch this video. Thanks for subscribing to my channel, and until next time, everybody, take care and God bless.